Good day everyone. This is the second video we're doing on differentiation under calculus, and today we are just going to be looking at some basic things and some few calculations. Now we have basic rules in differentiation achieved by first principle. We have different kind of differentiation. We have differentiation using first principle. We have using second principle. We have chain rule. We have product rule, we have quotient rule, we have implicit differentiation, and you also have logarithmic differentiation. Do you understand? So now let's quickly dive into what we have for today. But before we dive into what we have today, the question you are given will determine which kind of rule you are going to apply to the differentiation or to the question. So whether it is chain rule you are going to apply, it will be dependent on the way the question appear, or whether it's product rule, it will depend on the way the question appear, or quotient rule and the likes. Do you get it now? Now let's quickly look at this. Now you have number one, you have if c is a constant, then the derivative of c is equals to 0. That is, when you differentiate a constant, like when you differentiate, let's say we have y equals to 5, so your dy dx will give us 0. If y is equal to a constant 5, 10, 20, 1 million, whatsoever, so far there is no variable attached to it, then dy dx is equal to what? 0. Is it clear now? Now let's move to number 2. We have if a is a constant, then d dx of a of f of x is equal to a d dx of what? F of x. Right there now. So we can also say this one now. Let's say we have something like, if we have what? Y equals to 2x. Right there now. We can also rewrite it as what? Or we can say dy dx or d dx, same thing as what? Yeah, we can put your 2 there and can put your x here. Same thing as this, and this one is same thing as dy dx of what? Differentiation of what? When you want to differentiate 2x. Right there now. If you want to differentiate 2x, the same thing as bringing the 2 at the other side of the derivative and what? Differentiating x, you are still going to get the same answer, because when you differentiate x you get 1 and you can still multiply with 2. It's clear. So that's what this one is saying. Now we have if u, v, w are functions of x, the sum is equals to this. Now derivative of each of them should be equal to, that means you differentiate each of them accordingly. Now what this one is trying to say, that if you have, let's say you have 2a plus 3b plus 4c, and want to differentiate with respect to x, with respect to u, with respect to v, with respect to w, like that. Do you understand? So it can even be the same thing. Let's say the same variable. Let's say u is 2x, v is 4x, and w is 10x. I don't know. Let's say 10x squared. I want to find d dx of this one. So if you want to find d dx of this one, you know that you are going to differentiate just like this one, du dx. That du dx, the differentiation of this one, you differentiate this one separately, you get 2. Differentiate this one also separately, you get 4. Differentiate this one also separately, you get what? You use the other power, which we are still going to do. This one you get 20x. I don't know. So that's what this one just trying to tell us. Now we also have product rule. Product rule is what? When you have product of two functions. So anytime you have product of two things, maybe you want to differentiate a function, and then what you have there, let's say we have what? Y equals to uv. You want to differentiate a function like this that is having a kind of a product. U can be anything, v can be anything. So far as having a kind of product, then you can use what? Product rule. That's the only time you have to use product rule. The only time you have to use product rule when you have product of two different functions. We are still going to dwell a little, or we are still going to do more questions of this. So this one is just a basic explanation. We also have quotient rule. Quotient rule is what? This is the formula for quotient rule. That is when you have what? When you have a function whereby it is a form of fraction like this, that's when you use quotient rule. When it is form of multiplication, you use what? Product rule. When it's form of fraction, you use what? Quotient rule. So this one, what I'm trying to do here is just trying to brief you on the general knowledge of everything before we now start picking it one after the other. Is it clear? Now, you also have chain rule. Chain rule is what we call function of a function. That is, chain rule is when you have, let's say, chain rule is the I will still explain more on this later on. The formula for chain rule is dy dx equals to dy dz times dz dx. Take note that this z can be anything. You can decide to use your own formulas: dy dx over dy du times du over dx. You can decide to change it. As you can, me, I like using dy dx equals to dy du times du dx. This is what I like using most. So it can be any what letter. Is it clear? So also have, if y is a function of x, then dy dx should be 1 over dy over dx. You get it now. So this one is still the same thing as this. If you solve this, you see that it's still the same thing. There's nothing new about that. Now let's move to the first form of solving differentiation, that is using second principle. That is when you have dy dx equals to n times, okay, when you have y equals to a times ax raised to power n. Then how do you differentiate it? What you do is what you bring this one down, you bring the power down, and you subtract 1 from the power, and that's what is going on here. Now let's differentiate the following. Now let's start solving some questions. Now differentiate the following with respect to their variable. Now if you have y equals to x squared, you can easily use second principle to solve this. So how do you solve this? First thing first is what, using this formula, using second principle, you have the y equals to x squared. What you do is bring down the power and subtract 1 from the power. Now bring it down to, you have 2 minus 1. You get now. So you have 2x raised to power what? 1. So the answer is 2x. Now another one, when you have y equals to 3x raised to power 5, bring down the power, that's 5, minus subtract 1 from the power, minus 1. So 5 times 3 is 15. This one gives us what? 4. So you have what? This as your answer. Let's look at another one. You have y equals to 14x squared. So how do you do this? Bring down the power and subtract 1 from the power. So bringing down the power, you have 2 times what? 14 times x, 2 minus 1. Do you get it now? So this one gives us 28 times x raised to power 1, which is the same thing as what? 28x. Alright, so let's look at this one too. Y equals to minus 12 x raised to power 6. Bring down the power, you have 6 here. Subtract 1 from 6. Subtract 1 from 6, you have what? 5. And minus 12 times 6, you give us minus 72. And these are how we can solve differentiation. So there are many other examples there. Now also, let's say you have y equals to 3x cubed, and you have to find dy dt. Now how do you find dy dt? Now this will be your take home, so go and try it. Let's say, yeah, also let's say you have z equals to 4x cubed minus plus 5x. Say you find dz dx. How do you find this? And also you can also find d squared z over the x squared. How do you find this? So use this as your try assignment for you to test how you can solve differentiation. Now I think this is all for today. So in the next class or in the next video, we'll talk on the following, the next subtopic. Thank you.